Isn't this number I'm almost done.
I'm almost about to collect it.
So what's in it?
Oh, positive.
And the other is for every time.
And the water. Alright, so don't forget, if there's any of this that you were struggling with, this might be a good time to take some notes, maybe add some more to the graphic organizer, just get out a sheet of paper, something, right? So that we are focused, dialed in, and ready to discuss.
Okay. I'll write this right. I could be wrong.
That sounds like a good place to take some notes.
Like on the indicator, I
Yeah.
know the X's because they're like already like determined. I just can't figure out the Y.
It's a good note that the X's are already determined.
If it's going down, is it always negative? Because like on this side of the X thing is positive, but then if it just shoots down from there, then Y
We'll
will.
talk about it. Okay, so what is the range of the function to the right? I see a lot of us did negative infinity to 4.85. I see a 0 to 4.85. A lot of us were thinking negative infinity to 4.85. So how are we supposed to figure out the answer here? I mean, we had the graph, right?
Find the maximum
Yeah,
Y
the
value.
maximum.
Right, so if I look at this graph here, I needed to know what the, well, first off, let's say this. Do not forget that we start our interval notation with the what?
Minimum.
Minimum, right? If we're talking about range, which variable are we talking about? The y, okay? So KJ, if you look here at the y, what is the lowest y value that I have?
Negative.
Alright, it's going to keep going down, right? On both sides here, it keeps going down to negative infinity. Alright? But then, what is the maximum y value? How'd you get that? Okay? And so this is what we would consider an absolute maximum. We'll talk about that a little bit today. But notice it's a 4.85 here. Now, I want to point out that the top set of answers that we had 3 and 3 of, there's a slight difference in these answers. It might be hard to tell, but does anyone want to guess what the difference between these two answers is? Bracket and parentheses, okay. So which one is it supposed to be with that 4.85? It's supposed to be a bracket. Because you can equal that 4.85, or the function equals that 4.85. So the maximum was 4.85, and it's equaled. Okay? Now, when it comes to the domain, I saw a couple of answers as I was walking around, but this one should have been pretty straightforward. I'm looking and I have no clue what the difference between the top and second answer is. I don't even know.
It's the negative thing.
Oh, it's because they put a minus instead of a negative.
Oh, I did.
That's
I
what
did
it is.
that. I put a minus.
Okay.
Where even is the negative sign?
Bottom right hand corner near the enter.
Right below.
That's the minus sign.
That's the negative.
Oh, that, yeah, I never did that.
Okay, that's a negative. You might want to start using that. Okay, so it looks like everyone eventually got to the fact that the domain is negative infinity and positive infinity. Because domain, what are we talking about? The x. And is it ever going to stop going to the left? No. Is it ever going to stop going to the right? No. And don't forget, another thing that we talked about with the domain is it's all of the inputs, right? Is there any number that I cannot plug into the equation? No. That's why it's negative infinity to positive infinity. I can plug any x into the equation. So that's good on domain and range. Then we had roots and their multiplicity. -2, 1, 1. Okay. So for the most part, it looks like we were on very similar pages. I will say, like in this third answer choice right here, it says all of these have a multiplicity of 2. But I believe that the equation was f of x equals x plus 2 squared times x minus 1 times x plus 1. So one thing I'm very glad to see is all of us, we are recognizing that to write a root, we have to write it as x equals, right? But right here, it's not a multiplicity of 4. Does anyone know what would be 4 here? The degree, right? The polynomial has a degree 4, right? Because that's the sum of all those powers. But if I talk about this root here, x equals negative 2, how many times does that root show up? Twice. There's as an exponent of 2. You awake with me, KJ? Okay. Jaden, you paying attention? So x equals negative 2, that's a root, it shows up twice. X equals 1, that's a root, it shows up once, multiplicity of 1. And x equals negative 1 from the last one, multiplicity of 1. So a lot of us were there or very close to there. Any questions about any of those? And why those multiplicities are 1, right? So we see a couple here where we thought it was 2, multiplicity of 4. I do want to point this out. What does the multiplicity always sum up to equal? The degree, right? Don't notice that, right? The multiplicity should always add up to be the degree. That's an important detail. At least once we get into the complex roots, because you can't have complex roots and then the multiplicity should always add up to be that. The product, none of us got to the product part.
I pushed the arrow.
Oh, I lied. I totally took that one off so that you couldn't even see it. It's still technically there, but I made it small so you couldn't see it. Because I didn't want to waste the time on that one. Not wasted, but... Okay, so left hand in behavior. Let's start there. As x approaches negative infinity, y is approaching... Most of us are saying negative infinity. One thing I do want to clarify. So when I look at these answer choices, it is as x does this, y is doing something, right? So you don't have to put the as twice. As the x does this thing, y is doing something. So we don't need the as, but we do need the as, right? So it's as x does something. And this is just a rough sketch, but I think it looks something like this, right? So as it goes to the left, what's my y doing? Going down, right? So y is approaching negative infinity. And then as x goes towards the right-hand in behavior, my y is also still going down towards negative infinity, right? And the reason why it's infinity, and Gracie, I think you had a question about the positive or negative infinity, right? Just remember, these numbers right here are negative. So it's never going to stop, which is why it's an infinity, but it's in the negative area, so it's negative infinity. With the x, right, it's going to the left to start for the left-hand in behavior. Notice those are negatives, so it's going towards negative infinity. Whereas the numbers on the right are positive, so it's going to the right towards a positive infinity. That's how we tell the difference, right? Is it in a positive or negative direction? Any other questions before we move on and get into today's lesson? Going once, going twice. Too bad it's sold. All right. So our agenda is hopefully to finish up lesson 3, polywog, key characteristics of polynomials, which y'all can totally see because I have it written all over the board. I think I put what page it is in a second. Let me check. Nope, I did not put what page. But you should already have it from yesterday. To what?
Where we stopped yesterday?
Yeah, where did we stop yesterday? To what? 28. Okay. So yeah, 228 is where we are within that lesson 3. Alright. But after we get done with lesson 3, I do have an understanding check. Again, remember, an understanding check is literally that. It's not a quiz. It is a check to see where your understanding is, to see what I need to cover with bell ringers again, to make sure we understand these things. And then if you do better on the test, I replace the understanding check grades.
We've got finish it?
It's after we finish lesson 3, so if we finish it today, it's today, if we finish tomorrow, it's tomorrow.
I thought we was doing, yeah, I thought we was doing like practice work.
We're doing what?
Not practice work, for
Yes, this lesson 3 is the practice.
Okay.
Like, we've pretty much covered everything except for the increasing and decreasing. That's the only new thing that we're learning in this lesson. And I don't even remember if I put that on this understanding check. It's over here somewhere. I'll have to find it in a second. I don't know if you can tell, but my desk is cluttered. It's fine. Yeah, honestly, it stresses me out as well. Yes, thank you. I had this, meant to have this on there earlier. I do need your homework, but KJ, you know there's like a whole, all of that packet that you had to turn into. Yeah, so you did this part too. It's the review packet that we use to get ready for the quadratics test.
It looks like this.
Yes, valid. It says skills practice. Check to make sure you actually did those problems. The graphic organizer is also due today. Yep.
What?
We have too much homework, I'm gonna have a bad grade just because I don't know what to, like, do. There's just too many. I'm behind on like 10 different pages.
So there was this weird thing where I sent out an email last Thursday that had the slides.
Email.
Okay, well, we need to fix that. I put up the homework every single day. The homework has everything on there that is due this week. That was due yesterday, due today, and due on Friday on there. So I would take a picture of it.
I'll turn it over.
Okay.
I don't know about the whole review. I did this.
How about this then? How many of us actually did both sets of things? DJ, one set. Alright, I'm gonna let DJ take a couple of extra bonus points then. The rest of y'all get it to me tomorrow. Did you finish everything?
I didn't know.
I mean,
And get it to me tomorrow. I think that is as nice as it gets. Alright, so DJ, remind me to give you those bonus points, and I'll go ahead and collect yours. So, please note that does not mean the homework gets moved back from Friday because homework is still due on Friday because, you know, Thanksgiving break. I'll put it up at the end of class so you can take a picture of it before you leave. Yeah. Okay, so we're on Polywog. Please notice again, we are practicing with all the key characteristics. We looked at this getting started yesterday, where we talked about the difference between the domain and range of the study versus the domain and range of the function itself. And so we're going to talk more about maximum and minimum today. But what we are on right now is this 3.1, right? We're going to do numbers 1 through 3. We started to talk about number 4 yesterday. And one thing I want to remind you about, did we do both increasing and decreasing yesterday, or just the increasing? We did do both? Okay. So one thing I want you to remember with this increasing and decreasing, students have traditionally struggled with increasing and decreasing heavily, which is why I am calling it something slightly different than just increasing and decreasing. This is something I talked about with Ms. Dennis as well, that students have been struggling with increasing and decreasing, so I talked about using this language. Instead of just saying increase, what did I say yesterday? You should have written it down. Domain, intervals. Alright. Domain intervals for which the function increases. That is a mouthful. However, that is the most accurate way to say this, and it will help you significantly, because when you're talking about increasing, should you ever write numbers down for the y values? No. It is a domain interval, so we are only talking about what? Domain, which was which variable? X, right? Another thing to remember is we talked about the increasing and decreasing very closely related to the maximum and minimum. Because notice, from that minimum to this maximum, the function is what? It's increasing. That going up idea is increasing, and that's why we approximated this as, was that 5 point, I think we said 6, didn't we? 6, comma, and 23, okay? So, that's what we're saying is, from the x value of 6, from 6 months until about 23 months, the frog egg population increases, right? And that's what we're really saying. Now, what I want us to do is, we did these approximations yesterday using a calculator, right? So go ahead and get your calculator out. I want us to figure out more accurately what those domain intervals are. Don't forget the equation is given to you right here. It's in your book. So let's figure out more accurately what those domain intervals are. And then we want the domain intervals for which the function decreases as well. So write those domain intervals for which the function increases and the domain intervals for which the function decreases.
They did their like testing. They should have done it by like those specific months, because that's like not even accurate.
What do you mean?
Like there's 12 months, so at 12, it should have repeated what it was doing, because in December, there probably ain't as many tadpoles as there are, and you know, like summer.
But, I mean, that's just not how it worked out for these frog eggs.
Because they're,
I don't think you can tell them they're wrong, they just collected those data.
I know, that's
The
just
data
like,
is what the data
how many-
is, you can't control the data.
how many months are there? Like 12, 24,
I mean, they collected the data, it looks
36,
like
42, 50,
over 4
yeah.
years or so.
Yeah, that's what I was saying.
But like,
It was, yeah, it doesn't make sense though, because once it like, let's say it goes up for summer, and then down for January or something, then it should have gone right back up
You
to
don't
theirs.
necessarily have to use crystal like little.
right, but it's not necessarily following that
I know,
order.
usually there's just
But,
like a
like,
trend.
But if you think about cicadas, there's 17-year cicadas or something like that, which means that they only hatch every 17 years.
Well, they got like migrations and stuff, like tadpoles just kind of.
Maybe not, but these are frog eggs, and, well, I guess, so it's focusing on the frog eggs, and it's the average number of frog eggs.
Yeah, about to say, that could be, yeah,
Yes, sir.
that's not how many actually live.
Wait, we gotta do some math.
Because it was too cold and they
Yeah.
lay eggs, they
So, yeah, you gotta finish those, don't you? Some of those. No, so notice I gave you directions on which ones to do. Quadratic, so lesson 4, parts B and D. So like if you look, so that's 6. There's 4. So there's 4, not A, but do D, and just do D. So those. And then when you get to lesson 5, solving quadratic equations, notice you only have to do, not even that, you only have to do part C, which is, oh yeah, it's right here, part C, and it's just 5 of those 10. Right, so that's, follow those directions for that. Okay, it'll help if you have this in order. It's like, I don't even think you have anything off that first page, so that's the order it's supposed to be in. Okay? Okay. Well, remember, I'm letting y'all turn it in tomorrow for no, or, yeah, tomorrow for no quiz. Is the graph not on the next page? Oh, no, it's not. So, you need to type in that equation. Because remember, I need you to.
Well, no, I did that last time and it didn't give me, and it gave me like, I kept zooming out, zooming in, and it never showed me.
Did you ever try to do window settings for the window that they have there?
It's too large.
So like, what is the minimum x value, what's the maximum x value? Right, so use the window. Hey, by the way, guys, when you graph this, graph it according to the window that they have on the paper. That'll make your life way easier. That's fine.
I got nothing like what